All right, the next set of problems, the directions say to use a calculator to determine each of the following and round to 2 decimal places. So I have the sine of 72.8 degrees that I need to deal with. Let's first of all look at what our mode is set to on our calculators. So if I go to mode, actually the first thing that pops up here on my calculators, I'm in scientific notation because that's what I was doing with my intermediate algebra class yesterday. So I want to be sure that I'm in regular notation. And I want to be in degrees so that radian thing is highlighted right now. I want to be in degrees, so press enter there. So degrees is highlighted and I quit. So we're in degrees there. Similar thing with this calculator. Mode, I need to be in degrees here, so I am, and I do not need to be in scientific notation. So now we just stick this in the calculator. Sine of 72.8. Sine 72.8. So we get, what are we supposed to round it to? 2 decimal places. So 0.96. The most common mistake that students make, and the most common mistake that I make in this class, is just picking up my calculator and trying to put my problem in without paying attention to what mode my calculator is in. You know, because sometimes you may be doing a set of homework problems and you may have 3 problems in a row where you're in degrees, and then all of a sudden you have a radian problem. And, you know, then once you do the problem, you realize, oh, I was in the wrong mode. So problem 12 was degrees. Problem 13, we're in radians. Now, I want to point something out about this problem. I'm not told that this is radians, and you cannot just assume that if it has a pi, it's radians, and if it doesn't have a pi, it's degrees. If it has degrees, if you're in degrees, it's going to have that degree symbol. If you do not have that degree symbol, you're in radians, whether you have the pi there or not. Does that make sense? Okay. So degrees is going to have a degree symbol. Otherwise, you're in radians. All right, so problem 13, I want to find the cosine of 3 pi over 8. I'm in radians, so I'm going to go to my mode calculator. Down there, we're in radians. And then here, mode, radians. And I want cosine of 3 pi over 8. Cosine of 3 pi divided by 8. So here, cosine of 3 pi divided by 8. And that is approximately 0.38. Now, problem 14, we're asked to find the secant of 40 degrees. Well, there's no secant button on your calculator. You've got sine, cosine, and tangent, and then you have the inverses of those, inverse functions of those, which we haven't talked about quite yet. So let's go back to our reference sheet and see what we know about secant. Well, secant, using my reciprocal identity, is 1 divided by cosine. Okay, so secant of 40 degrees is 1 divided by the cosine of 40 degrees. So we're back in degree mode. width there. And mode here, degrees. So we want 1 divided by cosine of 40. 1 divided by cosine of 40. And that's approximately 1.31. On problem 15 and 16, theta is an acute angle, right? Now, so far, that's the only type of angles that we've been working with, but later on, that part of the directions will be important for us, just so you'll know. The things will change eventually. Right now, the only thing we know is that theta is an acute angle. All right, so problem 15. I know cosine of theta is 0.8. Well, if I want to figure out what theta is, it's kind of like me just going backwards and doing an inverse. Right? So that's exactly what they're called. These are inverse operations. So my theta is going to equal the inverse cosine of 0.8. If you remember from college algebra, when we started talking about logarithms, we actually started talking about inverse functions. If I have a function f of x that I'm given, I can switch the x's and y's around and come up with the inverse of that function. And the notation that we had looks like this. This is not an exponent of -1. These are inverses. And that's what this means. And if you look on your calculators, those are second function buttons. And it's hard to see on my 84. It's a little bit easier to see on the TI-30. You've got the inverse functions as the second function buttons for these. And that's the last problem we did. We were in degrees, right? And we're still in degrees here. So I'm going to hit the second button and then cosine. And notice I have this come up on my calculator with that little -1 symbol. And that's going to be 36.87. Okay. Same thing right here, inverse cosine of 0.8, 36.87. So theta is approximately 36.87 degrees. We're going to do these problems. Again, we're going to see these type of problems again later on in the semester. Not really sure why they have them in here twice, but we do. Distance across the lake A is unknown. To find this distance, the surveyor took the measurement shown in the figure. What is the distance across the lake and round to the nearest yard? So I'm looking at this angle of 24 degrees, and I've got these two measurements here of opposite side and the adjacent side. Well, I know with my 6 basic trig functions, it's either tangent or cotangent that I could use to do a relationship with. But since my calculator doesn't do cotangents, I'm going to do tangent. So the tangent of 24 degrees is A over 750. All right, so first thing, I know when I wrote down degrees, I need my calculator to be in degree mode. So I think the last problem we did was in radians, so be sure your calculator's back in degree mode. And I have to solve this equation. It's just like solving this equation. 7 equals x over 2. How would I solve this equation? Not divide by 2, but multiply both sides of my equation by 2. So those would cancel. So X is 14. All right, so it's a similar thing here. I'm going to multiply by 750. So that will cancel. So A is 750 times the tangent of 24 degrees. I just need to stick that in my calculator. 750, the tangent of 24 degrees. And to the nearest yard, that's 334 yards. Okay, problem 18, a ladder is leaning against a tree and it reaches 8 feet up the tree. That's parts 8. The angle the ladder makes with the ground is 25 degrees. How long is the ladder? Okay. Now, if I wanted to resketch this into a triangle, that's 25 degrees. This is X, this is 8. So if I'm looking at this angle measure, I'm looking at opposite over hypotenuse. So what trig function is that? Sine. So sine of 25 degrees is 8 over X. Hopefully y'all remember from college algebra, when you have a variable in your denominator, and you want to get that variable out of your denominator, you go to multiply both sides by your least common denominator. In this case, it's just X. So multiply both sides of my equation by X. This cancels. So I have X times the sine of 25 degrees equals 8. This is just like having say X times 3 equals 17. The way that I would solve this is to do the inverse of multiplying by 3, which is dividing by 3, and they cancel. So sine of 25 degrees is not a nice, cute little number like 3, but it's still just a number. So we're going to divide both sides of my equation by sine of 25 degrees. So I have 8 divided by sine of 25, and that's going to give me approximately 18.9 feet. Any questions with that? Okay. Let me give y'all a chance to try to set up problem 19 on your own. All right, so which trig function are you going to use? Sine, cosine, tangent? Sine, right? So sine of 60 degrees is opposite over hypotenuse, right? This distance here is X. That's what we're trying to find. How do I go about solving this? Okay. Multiply by 30. This cancels. So X is sine of 60 times 30. So that's approximately 26 meters. Is it meters? We're in meters. Yeah. Okay. Be careful with solving problems when your variable is in the numerator compared to when your variable is in the denominator. Be sure you know how to solve each type. Find an angle of elevation of the sun when a tree that is 24 feet tall casts a shadow that is 9 feet long. One thing you will learn about me real quick is I am awful with pictures. It's about as good of a tree as I can get. 24 feet tall tree, and the shadow is 9 feet. I've got the sun up here and it's shining, well, sun's over here, right? And then it's shining down, and this angle of elevation to the sun is what I'm looking for. So I have opposite and adjacent sides to this angle theta. Well, again, if I'm looking opposite over adjacent, it's either, or if I have opposite and adjacent, I have to either make a relationship with cotangent or tangent. And my calculator does tangent. So I'm going to say the tangent of theta is opposite over adjacent, 24/9. Well, I want to figure out theta, so I need to do the inverse. So theta is going to be the inverse tangent of 24/9. So I can put that in the calculator as 24 divided by 9. So inverse tangent 24 divided by 9. And that's approximately 69.4 degrees. Okay, problem 21. I'm going to try that one on your own. Okay, we're dealing with sine, cosine, or tangent. Okay. So my cosine of theta equals what? 10/14. And then theta is going to be inverse cosine 10/14. You stick that into your calculator and you get approximately 44.4, I believe. From the top of a lighthouse, 61 feet high, the angle of depression to a small boat is 41 degrees. How far from the foot of the lighthouse is the boat? Notice that I have an angle theta marked in my diagram. The angle that I have sketched out in yellow is the angle of depression, and it is equal to the angle of elevation from the boat to the top of the lighthouse. If you remember from high school geometry, when you have two parallel lines cut by a transversal, alternate interior angles are congruent, and that's what we have here. So the angle of depression is 41 degrees. The angle of elevation from the boat to the top of the lighthouse is also 41 degrees. And I know that the lighthouse is 61 feet tall, and I am asked to find this distance from the boat to the lighthouse. When I look at this angle of 41 degrees that's in my right triangle, and I notice that I have 61 and x, those are the opposite sides and adjacent sides, so that tells me that I'm going to be using the tangent function. The tangent is opposite over adjacent, so the tangent of 41 degrees is 61 over x. Now to get that variable x out from under the denominator, I need to multiply both sides of my equation by x. And then from there, my x's on the right-hand side are going to cancel, and on the left-hand side, I have x times tangent of 41 degrees, and that's going to equal 61. Now I divide both sides of my equation by tangent of 41 degrees. So x is equal to 61 divided by the tangent of 41 degrees, and that's going to be approximately 70 feet.